We are going to be working on 3BBB, which is basically a review of graphing linear equations. So our content objective is students will be able to graph linear equations. Our language objective, students will be able to discuss various methods of graphing linear equations, and in this case also discussing different methods of finding the equation of a graph. Why am I learning this? Well, it's important for many topics for next year, so we want to make sure we're comfortable with graphing as well as determining an equation of a line. So, first things first, what I want to talk to you about is the unit rate. Okay, I want you to be able to look at a graph and be able to tell me, is my unit rate going to be positive or is it going to be negative? We're going to be using the word unit rate for now, but you're going to later learn that it's going to be a different word. So right now we're using unit rate, but just expect that in the future we're going to be shifting that word to something else. So look here, it says you must start at the left when reading graphs. Kind of like the way I would read the sentence. I would read it, determine if the unit rate is positive or negative. I'm reading from left to right. I don't read from right to left because that would seem strange to say negative or positive is rate, unit, the, if, determine. So reading graphs is the same way. We read from left to right. So here, what you would want to do is place your finger farthest to the left and trace your line. So in this case, you'll notice that the finger traced downwards. Because that it did, we would call this a negative unit rate. And the reason why is because the line went down as we were reading it from left to right. Now let's look at our second example. Here, again, we must start farthest left. So I'm going to go ahead and place my finger on the left, and I'm going to trace it towards the right. As I traced it to the right, you'll notice it was going up. So I'm going to say that it is a positive unit rate. And why? Because the line went up as we were reading it from left to right. So now I want you to practice. Here, go ahead and try numbers 3 and 4 on your own. Go ahead and pause the video and see what you think it is. Okay, so now we're back. Number 3, let's go ahead and check. We're going to place our finger farthest to the left and trace. Since it went up, we're going to say that it's a positive unit rate. Why? Because the line went up from left to right. Well, what about 4? Again, you're going to place your finger farthest to the left. You're going to trace it. Here, you're going to notice it went down. So this is going to be negative. Why? Because the line went down from left to right. So it's that simple. This is going to be helpful for us for when we make our equation because it's going to help remind us, is my unit rate supposed to be positive or is my unit rate supposed to be negative? So now it says, find the equation that represents this linear relationship. So first things first, what I want you to do is let's look at the unit rate. And before we even start counting how many y for how many x, etc., I want us to decide right now, is it positive or is it negative? So we're going to place our finger farthest left. We're going to trace it from left to right. This, since it went up, I'm going to go ahead and say that it's a positive unit rate. So I'm going to keep that in mind. Now, in order to find the unit rate, what you need to do is determine 2 points on the line. You only need 2, technically. So I'm going to go ahead and pick 2 points, one here and one here. So now what we're going to do is we're going to see the change in y's in comparison to the change in x's. So here y runs up and down, so I'm going to count. It's going up 1, 2, 3y. So I'm going to go ahead and write that down, that it's 3y. Now in terms of x, it's going across 1, 2 x's. So I'm going to go ahead and put that over 2x. Now this is the same thing as 3 halves y. How I got that, technically what I did was I went ahead and split up the fraction as 3 halves. And the way that I got y per x was because I did y per x. And that's it. So now what you're going to do is you're going to look for initial value. Before we actually take a look at the initial value, I want you to notice something. Here, if we had a point at the origin, okay, and we drew the same exact line, this line here would be a proportional relationship, right? This one is not, and the only reason why it's not a proportional relationship is because it doesn't go through the origin. So if we take a look at this yellow line, our orange line, I would say this is a proportional relationship, so it should follow the form of y equals kx. In fact, since I know the constant of the unit rate, I could even say that it would be y equals 3/2 x. Now, the one thing that I want you to understand, though, is obviously this orange line is not the black line. But there's one slight difference. I could technically change this orange line to move it to the black line, and all I would have to do is shift it up once, twice, 3 times. Since it shifted up 3, all I would have to do to change this equation is make that adjustment of a shift of 3 upwards. So what I'm going to do is put plus 3. Guess what? This is my equation. Y equals 3/2 x plus 3. So the only thing different from a proportional relationship is the black line was shifted up 3, which requires me to put plus 3. Now, as for our initial value, it started right here, which is 0, 3. So here I can say at x equals 0, y equals 3. Okay, so now let's take a look at another example. So the instructions are exactly the same. We're going to find the equation that represents this linear relationship. So first things first, we're going to find the unit rate. But before we even go into that, what I wanted to do is just define whether or not it's positive or negative. So again, you're going to place your finger farthest to the left and trace it from left to right. You'll notice here that it traced downwards, so I would say that the unit rate is negative. Please make sure that you're keeping in mind that our final answer should have a negative unit rate. So here, for my unit rate, I'm going to pick 2 points. Okay, I'm going to pick this point here and this point here. So now what we're going to do is we're going to start counting to compare our y's in terms of x's. So here I'm going to say that there is 1, 2, 3, 4 y's. Since it went down, I consider them negative. For every, let's see, 1, 2 x's. So notice I went ahead and wrote it as a fraction. So now you can also read this as negative 4y per 2x. Guess what? This can be rewritten as negative 4/2 y per x. So once more, what I did here was I split this up to create a fraction, that negative 4/2, and then in order to get y per x, I just did y per x, and that's it. Now, something that I want you to realize, though, is that this is not reduced. In fact, this can be reduced to negative 2y per x. Now, let me talk about something else. So notice you could have used these 2 points. However, what if instead I used 2 points that were a little bit closer, like this point and this point here? Well, if I use these 2 points, they're closer, which is preferred because then you're not going to have to reduce in a case like this. Watch what happens. I'm still going to find the change in y. So in this case, I'm noticing it's dropping down 1, 2y. So since it's dropping down, it's negative 2y. And then here, it's going over 1x. So I'm going to say negative 2y per 1x. Guess what? Negative 2 over 1 will still reduce to negative 2y per x. So it's the same thing. No matter which 2 points you choose, you're still going to get the same answer. Now let's look at the initial value. So once more, I want you to analyze this line here. This could have been a proportional relationship, but the one fact that's keeping it from being a proportional relationship is the fact that it does not run through the origin. So what if it did? Okay, like this orange line here. If it did, then it would be a proportional relationship and it would follow the form of y equals kx. So therefore, my equation would be y equals negative 2x. Okay, but obviously that's not the case, right? But what if we went ahead and shifted this line to see what we could do to make it into this actual line that we're trying to find the equation of. What you can do is shift this orange line down 1, 2, 3, 4, 5, 6. Since it shifted 6 downwards, okay, that means I'm going to have to take this original equation and subtract 6. And there you go, you have your equation. So now let's take a look back at our initial value. Okay, our initial value is right here. Originally, you would start at the origin, but it shifted downwards here. And this point we would say is 0, -6. So our initial value, we would say at x equals 0, y equals -6. So again, you can think of it as terms as originally it would start at the origin, but you know what? This line shifted down 6, and that's why we put -6 here. So think about that. Okay, so now let's just go ahead and move on to our next example here. Same instructions. First things first is I'm actually going to have you pause the video and try this one on your own. Okay, so hopefully the first thing that you decided to do was look at the unit rate. And what you would want to do first is trace this to see, starting at the left, to see whether or not it's negative or positive. So here, it's negative. Why? Because moving it from left to right, I traced it downward. So I'm going to say that it's negative. So here, let's pick 2 points. So I'm going to go ahead and pick this point and this point here. Now let's start counting. In terms of y, it's going down 1, 2, 3. So I'm going to go ahead and put -3y. And so far that's good because I do expect my unit rate to be negative. Now in terms of x, it's moving 1, 2, 3, 4 x's. So I'm going to put -3y per 4x. This is the same thing as -3/4 y per x. And once more, let me show you. I basically split this up as a fraction. And then I put y per x. And that's it. So now we're going to try to find the initial value. And in order to do that, what I want you to do is think of this line. It could have easily been a proportional relationship, but why is it not? Because it doesn't run through the origin. So what if we made it run through the origin like this? Let's think in terms of this orange line. This orange line is a proportional relationship, so it does follow the form y equals kx. And I know the unit rate is -3/4, so it should be y equals -3/4 x. But guess what? It's obviously not the black line, but I could shift this orange line to be the black line. I would have to shift it down 1, 2. Since it was a downward shift, okay, I would take the original equation and subtract 2 because it shifted downwards. So here is my equation. That's it. But let's go back to the initial value. Here, our initial value is right here. So I would say at x equals 0, y equals -2. But again, what I want you to think of is originally, if it was a proportional relationship, it would start at the origin. But to get to the line that I'm wanting to get to, it would have to shift down 1, 2, and that's why we would get this -2 here. So always have that in the back of your mind, thinking of it as a shift. Is it shifting upwards? If so, it's positive. If it's shifting downwards, it's negative. Okay, so now let's take a look at the next instructions. It says, create a table for the following equation to determine the ordered pairs that will be used to graph the equation. Oops, this is supposed to be a comma, and this should not be capitalized. So here, first things first, I want to create a table. So I'm going to go ahead and do that. You want to make sure you include a table with at least 3 points. That's going to be the bare minimum when you graph. So here, I'm going to create a table. Whoops, let's try that again. Let's create a table. We're going to label it X and Y, and we need at least 3 ordered pairs. So here, since the numbers are nice whole numbers, I'm just going to pick the easiest numbers I can think of, the very first one being the number 0. So what I'm going to do is go ahead and rewrite this equation, but instead of an x, I'm going to put a set of parentheses, like so. Now I'm going to go ahead and take the 0 and plug it in for x here. Now all I need to do is simplify. Y equals negative 2 times 0, which is 0, plus 3, which is 3. Now I'm going to continue this process. The next easiest number I can think of is 1. So again, I'm going to take this equation and rewrite it with parentheses for x. I'm going to take this 1 and plug it in for x and simplify. Y equals negative 2 times 1, which is negative 2. Negative 2 plus 3 is 1, so I'm going to put a 1 here. Now once more, I'm going to take this equation. Whoops, I went ahead of myself. Next thing I'm going to do is try the next easiest number, which is 2. I'm going to go ahead and take this equation and rewrite it with x as replacing x with parentheses. I'm going to go ahead and take 2 for x and replace it in for here. So here y equals negative 2 times 2, which is negative 4, plus 3 is negative 1. So the instructions ask for the ordered pairs. So here I would say the ordered pair is 0, 3, 1, 1, and 2, negative 1. And that's it. You would actually graph this, but to save ourselves some time, I'm just having you practice plugging in the values to see what ordered pairs you would have to graph for this equation. Now let's try one more example. Here I have a lot of students asking me, Miss saying, how do I graph it if there's a fraction? We did talk about it a few lessons ago, so I just want to remind you. So again, we're going to start with the table. We want to make sure we have at least 3 ordered pairs. That's going to be your bare minimum. Here I'm going to go ahead and label it as x and y. So first things first, you want to pick the easiest number possible, and that number is 0. You're going to go ahead and take this equation and rewrite it so that you have parentheses in for x. So that's what I have here. Now, since x equals 0, I'm going to go ahead and take 0 and plug it in the parentheses. So y equals 1/2 times 0, which is 0, minus 4, which is negative 4. Now, the next easiest number, what a lot of people would think, is 1. But I disagree. 1 is not going to be the easiest number because I'm going to end up with 1/2 times 1, which is 1/2, minus 4, which is negative 3 1/2. I prefer to work with whole numbers. So the way we avoid fractions is by using multiples of the denominator. Since my denominator is 2, I'm going to pick multiples of 2. So instead of using 1, I'm going to use a multiple of 2, which would be 2. So once more, I'm going to go ahead and copy this equation, but instead of putting x, I'll put parentheses. And I'm going to go ahead and plug in 2 for x. Here, I'm going to go purposely make it as a fraction, so it's going to be 2 over 1. So here, I'm going to notice that I can cross cancel. The 2's will cross cancel each other out, leaving me with 1 over 1, which is just 1. And 1 minus 4 will give me a negative 3. So I'm going to go ahead and write a negative 3 here. Now, again, we're going to choose multiples of 2. So the next multiple would be 4. So once more, I'm going to take this equation and rewrite it here with space for me to substitute a value in for x. So in this case, x equals 4. So here I'm going to purposely make it into a fraction. I'm going to put it 4 over 1. Here I can cross cancel. You should always be able to cross cancel so long as you're picking multiples of the denominator. So here I can divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So that leaves me with 1 times 2, which is 2, divided by 1 is just 2. And then so 2 minus 4 is going to be negative 2. So I'm going to go ahead and write that here. Now, once more, we want to follow instructions, and it says to determine the ordered pairs that would be used to graph this equation. So I would say the ordered pair is 0, negative 4, 2, negative 3, and 4, negative 2. Those are the ordered pairs. And there you go. So now what I'm going to have you do is I'm going to have you try some on your own. So go ahead and try number 3. Pause the video and see how you do. Okay, so welcome back. So let's see how well we did. So first things first, what we're going to do is create a table. And again, we need at least 3 ordered pairs. So the first things first, we're going to label it x and y. And then we're going to first pick the easiest number we can possibly think of, and hopefully in your mind, the easiest number is 0. You're going to go ahead and copy this equation, but instead of an x, you're going to put a set of parentheses so we can plug in values. So that's what I have here. So now I'm going to go ahead and say since x equals 0, I'm going to plug in a 0 here. So y equals negative 5 times 0, which is 0, plus 1 is a 1. We're going to repeat this process. The next easiest number would be 1. So you're going to take this, copy it down. Here, since x equals 1, I'm going to put 1 here. Y equals negative 5 times 1, which is negative 5. Negative 5 plus 1 is negative 4. So the next easiest number is going to be a 2. So again, you're going to take this equation. You're going to plug in 2 for x and simplify. Y equals negative 5 times 2, which is negative 10. Negative 10 plus 1, which is negative 9. Now again, to answer the question, I must list the ordered pairs. The ordered pairs would be 0, 1, 1, negative 4, and 2, negative 9. And that's it. Now I'm going to challenge you a little bit more, and I'm going to have you try number 4 on your own. Go ahead and pause the video and see how well you do. Okay, so we're back, so let's see how we did. So first things first, you're going to need a table. You're going to use, in this case, x and y. So first you think of what is the easiest number you can possibly think of. The number is 0. So what you're going to do here is, again, copy the equation with a space for x. We're going to go ahead and plug in 0 for x. So we're going to plug in 0 here. So y equals 2/5 times 0 is 0, minus 1 is negative 1. Now, again, the next easiest number is not going to be a 1, because then we're going to end up with a fraction. So in a case when we have a fraction, we're going to want to choose multiples of the denominator. Okay? It's going to allow you to get rid of the fractions and only have to work with whole numbers. In this case, so here I'm going to try out a 5 instead of a 1. So here, we're just going to copy this equation. We're going to plug in a 5 for x. I'm going to purposely write it as 5 over 1. I'm going to see that the 5's cancel each other out. So 2 over 1 is just 2, and 2 minus 1 would give me 1. Now the next value I would try is, because it has to be multiples of 5, I'm going to try out 10. So here, I'm rewriting the equation. I'm going to go ahead and plug in 10 into my value for x, but I'm going to purposely make it into a fraction, so it's going to be 10 over 1. I can cross cancel. 5 divided by 5 is 1. 10 divided by 5 is 2. 2 times 2 is 4. Divided by 1 is 4. 4 minus 1 is 3. So here, I'm going to have an output of 3. But again, to answer the question, I must list all of the ordered pairs. So it would be 0, negative 1. 5, 1, and 10, 3, and those are my ordered pairs that I would graph to represent this equation here. So hopefully this video has helped. Thank you so much for tuning in, and until next time, bye.